So underneath, less than or equal to, we have example 3. Example 3, 6n minus 1 is less than or equal to 3n plus 8. Okay, this time my variable is on both sides of the inequality. When we were doing this with equations, so when there was an equal sign, I told you to move the smaller one, right? Mm-hmm. Okay, with inequalities, that's the only way I want you to do it differently is I always want you to move the variables to the left, even if that means we're going to get a negative. We'll just divide it out later. But when we move variables to the left, it makes it easier for us to graph with the variable on the left, okay? So I just want you guys to, when we are doing inequalities, move the variables so that they end up on the left. So in this case, I'm going to subtract 3n so I can move them all to the left. Okay, so I'm taking 3n out of the right side and onto the left. It actually works out this case that it comes out positive, but it won't always be that way. 6n minus 3n gives me 3n minus 1, less than or equal to 8. And then add 1 to both sides. So 3n is less than or equal to 9. And divide both sides by 3. So our solutions are n less than or equal to 3. That means any n that is less than or equal to 3 is a solution. So, is 2 a solution? Is negative 12 a solution?
Yeah.
Is 3 a solution?
No.
Yes, because it can be equal to, right? So when we graph that on the number line, I'm going to do 0 in the middle. 1, 2, 3, 4, 5. We get to put a closed dot because we can use the endpoint. And all of the numbers that are less than 3 are going to the left. So anything that is 3 or less. All right, example 4 goes under greater than or equal to. Example 4 has 2 parts, part A and part B. Let's just worry about part A for right now. So part A, 10 minus 8A is greater than or equal to 2 times 5 minus 4A. Okay, so on the right-hand side, I see distributive properties. So let's distribute. That's going to give me 10 minus 8A on the left, greater than or equal to 10 minus 8A. Okay. Oh my gosh. Let's get all of the A's on the left-hand side. So I'm going to add 8A. But what happens? It cancels on both sides, right?
Yes.
So we end up with 10 greater than or equal to 10. Let me pose a question to you. Do not answer it out loud. Is this a true statement or a false statement? Think about your answer.
I got it.
How many of you, raise your hand, not your mouths, think this is a false statement? How many think it is a true statement? So we are about 50-50. Guys, question. Read this out loud. 10 greater than or equal 10. Let's read it again out loud all together. 10 greater than or equal to 10. Is 10 greater than 10?
No.
Is it equal to 10?
Yes.
Can it be equal to 10?
Yes.
So is this a true statement?
Yes.
So what is our solution? All real numbers. And remember, you can also use the symbol for all real numbers, which is just the block R.
Oh, yeah.
No, we do not use infinite solutions because technically all of these have infinite solutions because the numbers go on forever and ever. So part B, I know that it's not greater than or equal to. I'm just using greater than. 6m minus 5 greater than 7m plus 7 minus m. Okay. On this example, the first thing I would do is I would combine like terms on the right-hand side. So that's 6m minus 5 greater than 7m minus 1m is 6m plus 7. And I need to get all my m's on the left, so I'm going to subtract 6m from both sides. Oh my gosh, what happens? It cancels, and we end up with negative 5 greater than 7.
That's not true. No. That's incorrect.
Is that a true statement or a false statement?
False.
False. So we say there is no solution. And the symbol is a circle with the line through it. Okay? Question. What if in part A I got 10 greater than 10?
Same thing.
Is that all reals or is that no solution?
No solution.
That's no solution. You have to have the equal sign if you have the same numbers, okay? If I ended up with up here, if I ended up with like 7 greater than 3, that's true, so that's all real numbers. So a true statement is all real numbers. A false statement is no solution. So I'm going to write that just right next to it. True is all real numbers. False means no solution, okay? All right, so last example is a word problem. You are building a fence around your garden adjacent to your friend's garden. So I drew a little picture. Here's your friend's garden. Theirs has like nice little plants and stuff. And then here's yours. It's empty right now because you haven't started yet. You have at most, will you please underline at most? So you have at most 42 feet of fence. What are the possible lengths of your garden? Okay. So question, guys. We have 42 feet of fence. Is my fence creating the area or is it creating the perimeter? Perimeter. The perimeter. Let's, we're looking for the length, so let's label the length and the width. And then if I'm doing the perimeter, how do I find the perimeter? What do I do with all my sides? You add them together. So let's think about this. If I have 2 lengths and 2 widths, how could I write that? 2L plus 2W. Okay. Now, I had you underline the at most part. At most, I have 42 feet of fence. Can I use all 42 feet? Yes. Can I use 43 feet? No. Could I use 40 feet if I wanted to? Yes. So is my inequality going to be less than, greater than, less than or equal to, or greater than or equal to? Tell you. Okay, good. Less than or equal to. Because at most means we cannot go over the 42 feet. But we can use all 42 feet. Okay. Less than or equal to? 42. Okay, I have 2 variables in here, but don't I know what the width is? Yeah. 2L plus 2 times 12, less than or equal to 42. Okay, I'm running out of room. So, 2 times 12 gives me 24. I would then subtract 24, and then I would divide by 2. So we would end up with L is less than or equal to 9 feet. So that means, so I didn't show all my work, which is bad, but I ran out of room.
Bad.
Okay. So I am setting a bad example. 12 times 2 gives me 24. So I would subtract 24 from both sides, and that would give me 2L less than or equal to 18, and then I divide both sides by 2. So this means that each length, so this side of your fence, each side has to either be 9 feet or smaller. And that way you stay within the amount of fencing that you have. Does that make sense?
Yep.
That's inequalities, guys.